Hey there, RF pros. So you're out in the field, and suddenly your signals go dark. Communications just fail. Is it just an equipment glitch, or could it be something a bit more deliberate? Well, today we're opening up the field guide for radio frequency technicians, all about how you can detect, diagnose, and deal with intentional jamming. Let's get right into it.
Now, before we go any further, it's really important to put this all into context. What you're seeing here is part 15 of a 20-part tutorial. It's based on a comprehensive report from RFI detectives, and we're providing this strictly for educational and interference mitigation purposes, to help you do your job. And we have to be crystal clear about this. Using radio jamming equipment is illegal in most places around the world, and it comes with some serious penalties. This guide is for the defenders, the technicians in the field, definitely not for the offenders. So we're going to tackle this just like a detective case. First up, we'll get to know the offense, how jammers actually operate. Then we'll go on the scene to find the clues in the RF spectrum. After that, we're going to cover the official protocol for your response. And finally, we'll close the case with the core principles every single RF tech needs to have in their back pocket.
All right, let's dive into our first section, jamming, know the offense. The fundamental idea here is pretty simple. If you want to defeat a jammer, you've got to learn to think like one. Understanding their methods, their tools, their techniques, that's the absolute first step to making them ineffective. So, what is it we're actually looking for? At its heart, radio jamming is the deliberate transmission of electromagnetic energy. And trust me, that word, deliberate, that's everything. This isn't some accidental interference from a leaky microwave oven next door. Nope. Jamming is a hostile, intentional act. It's designed specifically to disrupt or completely deny communication on a targeted system. Your job is to spot the difference. So, how do we actually measure the problem when we're out in the field? Well, it all comes down to one key metric, the jamming to signal ratio, or JS for short. This is your bread and butter. It's simply a measure of the jamming signal's power compared to the legitimate signal you're trying to pick up. The higher that JS ratio climbs on your analyzer, the more your signal is getting totally drowned out. It's kind of like signal to noise, except in this case, the noise is actively fighting back.
Okay, section 2, on the scene, finding clues. We're in the field, systems are down, and your gut is telling you something's not right. So how do you go about finding the hard evidence to prove it?
This is where having a methodical process becomes your absolute best friend. It's a 4-step process. First, confirm the operational impact. What exactly failed? When? Where? You need to log everything. Second, get that spectrum analyzer out and compare the current mess against your baseline records. You do have baseline records, right? Third, characterize that suspicious signal. What's its bandwidth? Its power? Its nodulation? Get a full profile. And fourth, and this is a big one, rule out the simple stuff. Before you start yelling jammer, you have to be absolutely sure it's not just your own equipment failing. A systematic approach is just everything. So you're staring at your spectrum analysis. What are the fingerprints of a jammer? You're basically hunting for a few key clues. A suddenly raised noise floor across the entire band, that's a huge red flag. Same goes for a powerful, weird carrier that just pops up where it has no business being. Or maybe you'll see something more dynamic, like a signal that's rapidly sweeping across frequencies, or one that's firing in these structured rhythmic pulses. These are the telltale signs that you're not just dealing with random noise. It's also super important to remember that not all jammers are built the same. When you're in the field, you've got to quickly classify what you're up against. Are you looking at a high-power, military-grade system that's using advanced tricks like frequency hopping over a massive area? Or is it more likely a low-power, kind of unsophisticated civilian jammer that's just causing a very localized headache? The answer to that question completely changes your response. It tells you the scope of the problem and the potential threat level. That brings us to section 3, the protocol, your response. So you found the clues, you're pretty sure it's jamming. Now what? What's the standard operating procedure for hunting this thing down and getting it shut off? But look, before we even talk about the hunt, we have to talk about prep work. And this quote right here, it says it all. Without baseline documentation, it is difficult to determine what constitutes an anomaly. This is the golden rule, the absolute #1 rule of interference hunting. If you don't have a clean, detailed picture of what your RF environment looks like on a totally normal day, you're flying blind. You have no way of knowing what's truly out of place. This is exactly why continuous monitoring isn't a luxury, it's an absolute necessity. Okay, so with that foundation in place, the response protocol itself has 3 essential steps. First up, direction finding. Time to break out the directional antenna, take your bearings from a few different locations, and triangulate that source. Pinpoint it on a map.
Second, document everything, and I mean everything. Timestamps, measurements, screenshots, and especially raw IQ data captures. This becomes your chain of evidence. And third, regulatory notification. Look, this is not a job for vigilantes. Your role is to report the illegal activity to the proper authorities, armed with that rock-solid evidence you just painstakingly collected. Finally, let's close the case. Section 4, Core Principles and Future Challenges. We're going to wrap this up with the key ideas you really need to internalize, and then take a quick look at what's coming next in this constant cat and mouse game.
So, what are the big takeaways from our field guide today? Really, it all boils down to these 4 principles. 1. Master your fundamentals. The JS ratio, waveforms, basic physics, that stuff is your foundation. 2. Monitor continuously. I know we've said it before, but it is the most important rule. Baselines are everything. 3. Comply and report. Always follow the legal procedures. And 4. Stay current. The tech behind jamming is always evolving. Your knowledge has to evolve right along with it. And that brings us to our final thought, a little look to the future. Because this technology, it's not standing still. We're already seeing the rise of cognitive jammers that can listen and adapt in real time. So the question I'll leave you with is this. As the jammers get smarter, how will your diagnostic toolkit, and maybe more importantly, your own skills, need to evolve to keep up?